Hello everyone, welcome to the e-lecture series on power quality, module 2. I am Mr. Hadpeses, Assistant Professor in Electrical Engineering Department from Matosri College of Engineering and Research Center, Nasik. In this module, we'll cover the classification of power quality events. Let's take a quick review from the module 1. That in module 1, we just covered the introduction to power quality, good power quality characteristics, different stakeholders of the power quality, that is the people associated with the power quality, then importance of power quality, and lastly, if power quality is not maintained into the power system, then how it is affected to the system. So now in module 2, we are going to cover various types of transients, long duration voltage variation, its causes and effects, short duration voltage variation, its types such as sag, swell and interruption, and lastly we will cover voltage imbalance into the three-phase system. So let's go into the basic power quality classification. Now basically all the events into the power quality are classified into two types, that is stationary signal and the non-stationary signal. So non-stationary signals are basically a signal of voltage or current which shape is unpredictable in each cycle over the period of time are called non-stationary signals. Means if you observe here, it may be a graph of any quantity, that is voltage or current with respect to the time. Now here if we observe in this particular half cycle, here we could observe the transient, then next half cycle is of sinusoidal one, and next again if we go further, so here again another transient is there. So there is no any such a kind of periodic relation where transient will occur. Means what? The wave shape is not unpredictable, and that's why the things are not stationary into the waveform. Transients are not stationary into the waveform. That's why such type of waveforms are called non-stationary signals. But if we look at the stationary signals, then here we can observe, here basically three waveforms are shown. What they are exactly: the fundamental, third harmonic, the new harmonic waveform. So when we will go into the harmonics, in that chapter we will see what exactly these third harmonics, then fifth harmonic, there are certain levels of harmonics are there. But here our main focus is on the wave shape. So in stationary signal, if you observe, suppose if I take the example of this blue signal, this signal in every cycle, the repetition of its magnitude is same in every cycle. The wave shape doesn't change in a positive or whether it may be negative, or if you see the cyclic repetition, it is also same. Similarly, in if we take the example of this red signal, in this signal also, though it is not a sinusoidal signal, but still it is a stationary signal. You need to understand the difference between it. So this signal is of periodic symmetry is there. That means after each cycle, same wave shape is repeated. That's why it is called the stationary signal. So that's why it is a signal in which wave shape is same in each cycle over the period of time. It is called the stationary signal of the harmonics. That is example is harmonics here. Now here we are going to cover the different power quality issues like transient. Now it is divided into two parts, that is impulsive transient and the oscillatory transients. Then next power quality issue is long duration voltage variation. Again it has two types, overvoltages and undervoltages. Third issue of power quality, which is short duration voltage, it has also two types, that is voltage sag and voltage swell. Next is voltage imbalance, and of course it is occurred into the three-phase system that we are going to see. The next is flicker, then notches, and DC offset, and last is harmonics. Now let's start with the transient. So transient, it is the term which is used into the power system analysis for the very long time. So transients are nothing but the variations to denote an event that is undesirable and momentary in nature. So what is the meaning of undesirable and the momentary in nature? That is, they can occur into any time into the power system. They don't have any kind of specific time or a specific magnitude. So that's why they are called undesirable, and they are appear for very short period of time in microsecond or in millisecond. So that's why they are momentary in nature. Now these transients are divided into two categories, that is impulsive transient and the oscillatory transient. Now the name itself here indicates what is impulsive and the oscillatory, because in science and technology whatever the names given to particular thing are has their meaning, they have some meaning. So let's understand what exactly impulsive and the oscillatory transient. Impulsive transient is a sudden non-power frequency change in the steady state condition of voltage or current or both, that is unidirectional in polarity. The direction may be positive or it may be negative. So here every word of this definition has a specific meaning. So let's understand it. So it is a sudden. Now it is a sudden means what? No particular time event. Then non-power frequency change. It is not occurring at the frequency of 50 Hertz. The frequency of voltage or current where it is occur, it may change. In the steady state condition of voltage or current, it may occur in a voltage or it may occur in a current or both in unidirectional polarity. This unidirectional polarity makes a exact definition of an impulsive transient. That means when transients come into the voltage or a current, that it to the any one direction, that is positive direction or a negative direction. So here we can predict that when a transient is occurring at any one direction, and if we when we say the sinusoidal supply changes its direction continuously, that is positive and negative, so obviously transient will occur within a very short period of time, within a half cycle, because if it is come into the half cycle, then only it will has a positive or negative polarity. So here one example is also discussed, that is one particular impulsive transient. Its example is shown here in the diagram, that is caused due to the lightning stroke, and that lightning stroke is fall on the line of 2000 volt. The line and its value is 1.2 microsecond and then decays to half of its peak value in 50 microsecond. Means if we look at the diagram here, the transient occurs from 0 to minus more than 20 kilo ampere current, and it again slows down to its nominal value into the zero point 0.2 microsecond. Means we can say that we can predict the event at which it occurs and again it suddenly disappears. Next part of the transient, that is type of transient, is the oscillatory transient. Now in oscillatory transient, now we all know the oscillations. When we say that the oscillations, obviously oscillations are from positive side, negative side, right side, left side, that is called the oscillation. So now here the oscillatory transient is a sudden non-power frequency change in a steady state condition of voltage, current or both, that includes both positive and negative polarity values. So here is the again the point of difference, that in case of impulsive transient it is only at any one direction, but in oscillatory transient it is from positive or the negative polarity values. Again some things are common here, that is it is also sudden, that means again it is for the very short period of a time. Then it is also a non-power frequency change, that means it is not occurring at the exact 50 hertz. So that's why these words are here, you need to take care and need to understand it very carefully. Oscillatory transient is also a sudden non-power frequency change in steady state condition of voltage or current or both, that includes both positive and negative polarity values. Here we need to understand that it is also a same type of transient, that is it also come at the sudden stage, at any point it may come into the waveform. It is also a non-power frequency. Non-power frequency means what? Power frequency is of 50 Hertz. So non-power frequency means it is occurring at the frequency rather than 50 Hertz. Maybe it may be more or it may be less, but basically it is more. Why? Because it is in a very momentary nature. And it is also the change in a steady state condition of voltage or current or the both. So obviously it restores the original wave shape of the voltage or current. And the direction of oscillatory transient, it may be positive direction and the negative direction. So in both direction it is coming, and this point it differs from the impulsive transient. That in case of impulsive transient, the direction is unidirectional, but in oscillatory transient it is from positive and the negative direction, in the both direction. You can observe here into the graph that this wave shape is changing suddenly into the time period of, within the time period of 8 to 10 millisecond. It is whatever the phenomenon it is occurring, it is between 2 millisecond. And if we take the example of magnitude here, then magnitude is go beyond 7500 ampere current, and it is occur due to the switching of back-to-back capacitors from the reactive power compensation. So basically this transient with the primary frequency of component between 5 and 500 kilohertz with the duration measured in tens of microsecond. Now let's understand the next power quality event, that is long duration voltage variations. Now long duration voltage variations are nothing but the variations in RMS value of voltage or current at a power frequency longer than 1 minute. That means if voltage or current signal is deviated from its original value or original wave shape for longer than 1 minute within a power frequency, that means these variations are in a power frequency. Now these variations are divided into two parts, that is over voltages and the under voltages. So basically over voltages and under voltages are caused due to the load variations, and they are not the part of the system faults, or the we can say they are also caused by means of the switching operations, but due to faults they will not occur. Next we'll see one by one now. First, over voltages. The over voltage is an increase in RMS AC voltage greater than 110% at the power frequency for duration of longer than 1 minute. Now here from this diagram it is clear that green part indicates the normal waveform of the voltage, and when this voltage rises to its 110% value, here we can say that the magnitude of voltage is rises from its 100% value to above, that is 110%, and for the duration is longer than 1 minute. So such events are basically called as the over voltages. Now over voltages are usually the result of load switching, that is switching of large load or energizing a capacitor bank. Then they are also caused when system is too weak for the desired voltage regulation or voltage controls are inadequate. Means on a small we can say that the supply system we are applying a very large load, that in that case also these voltage over voltages might be occur. Another reason for over voltage also, that is the incorrect tap setting of the transformer. So for a particular less load, if taps are set at a very high voltage, then also over voltage causes might be there into the system. Now the next part is under voltages. Under voltages are exactly the reverse phenomenon, that is of the over voltages. Now under voltages are decrease in RMS AC voltage to less than 90% at the power frequency for a duration longer than 1 minute. Again here we need to remember that in both definition one thing is common, that is they are always occur at the duration longer than 1 minute. and here they are decrease in RMS voltage less than 90%. Now basically again undervoltages are the result of switching events. As we already discussed, they are not the cause of the fault. Now opposite of that event are the overvoltages. Exactly. A load switching on or a capacitor bank switching off can cause a undervoltage. A load switching or a capacitor bank switching off can cause a undervoltage until voltage regulation equipment on the system can bring the voltage back to the within tolerance limit. Means once you switch on the load or you switch off the capacitor bank. So obviously whatever the excess voltage, it has to appear across the terminal voltage of rest of the equipments from the same system, and that's why whatever the tolerance of that particular equipment, it has to sustain that high voltage or low voltage up to when any voltage regulation equipment will work in it. Overloaded circuits can also result into the undervoltages also. That is already the definition of undervoltage itself indicate that very we can say that overloaded circuits might be there, and due to that the every component from that system will not get a proper supply, so it may be the cause of a undervoltages. Next power quality event is the short duration voltage variations. Now in this category basically three types of short duration voltage variations are come, that is sag, swell and the interruption. Again they are divided on the another category, that is of its duration, that is instantaneous, momentary and temporary. At the end of module number 3, we will have a short summary of all the power quality events. In that, we'll understand the exact meaning of instantaneous, momentary or temporary kind of voltage variations. Now again here they are caused by the fault condition. Now it is very important that all the long duration voltage variations are caused due to the either switching operations or due to the load variations. But here all the short duration voltage variations are caused due to the fault condition, then the energization of large loads with required high starting current or intermittent loose connection into the power wiring. So according to the many power quality auditors, these particular problems are there. 80% problems are into the power system are due to the loose connections. Now depending on the fault location and the system condition, the fault either be temporary or it may be the complete loss of voltage. When it is temporary, it is again into two parts, that is it may be a voltage drop or it may be a voltage rise. Now the fault condition may be close to the point of common coupling, that is the point of our interest, or it may be near to the PCC. In either case, the impact on the voltage during the actual fault condition of the short duration variation until protective device operate to clear the fault. So obviously in case of when there is a voltage drop is there or voltage rise is there, so up till the particular your protective device will operate, and when there is a fault, so within that time of a span device has to sustain that kind of variations. Now we'll see one by one. The first one is the interruption. Now name itself indicate that interruption is the sudden loss of voltage, and that sudden loss of voltage, it is not more than the 1 minute. So it should be less than the 1 minute, and that's why it is called as the short duration voltage variation. The interruption can be either result of system fault, equipment failure and the control malfunctions. It may be any kind of reason. Then they are measured by their durations, since the voltage magnitude is always less than 10% of the nominal value. That means if you observe here in the graph also, that if you consider this green graph as its 100% value, then the complete loss or reduction of the voltage below its 10% level for duration of 3 seconds to 1 minute, not more than 1 minute. So such events into the power system are called the interruption. Now next is voltage sag, or they are also called dips. Now in case of voltage sag, it is a decrease of RMS value of voltage between 0.1 to 0.9 per unit at the power frequency for the duration from 0.5 cycle to 1 minute. Means here reduction of voltage is there. This first graph indicate that this red part, the reduction of voltage within the limit of 10 to 90% of the peak amplitude for the duration of not more than 1 minute. So this particular red part indicates the sag. Now the power quality community has used the term sag for many years to describe short duration voltage decrease. And here for comparison purpose, this graph is taken for the next power quality event, that is the swell. Now it is increase of RMS value of voltage in the range of 1.1 to 1.8 per unit in RMS voltage or current at the power frequency for duration from same, that is 0.5 cycle to 1 minute. Now here again in swell graph, the red part indicates the swell event. That green part is the normal voltage of 100%. Then if its value rises in the range from 110% to 180% within that particular span, if voltage rises and duration is again from point cycle to 1 minute. Now voltage sag or swell are generally associated with the fault condition, but they are not as common as voltage sag. Voltage imbalance is the another power quality event, that is nothing but the maximum deviation from the average of three-phase voltage or current divided by the average of three-phase voltage or current expressed into the percentage. Now here very simple we can say the technique to understand the voltage imbalance is, normally from the phasor diagram we can say that all the three phases are apart from each other by the 120 degree. But if from phasor diagram, if they are not apart from each other by 120 degree exact, then obviously there is a unbalanced system is there. And of course this unbalanced system is into the three-phase system, and of course this unbalanced phenomenon is occur only into the three-phase power system, not in a single phase, because it is the comparison kind of phenomenon with the reference. Now let's understand the causes of voltage imbalance. Very first reason for the voltage imbalance is less than 2% is single phase load on the three-phase circuit. That means it is the unbalanced distribution of the load on a three-phase circuit. In some cases, another reason is the blown fuses in one phase of a three-phase capacitor bank. That means one capacitor bank is not working and rest of two are working. So obviously this might be cause of unbalance. And most important reason for unbalance is single phasing condition, because normally these single phasing conditions are the temporary arrangement for the power supply. Let's look out the summary of module 2. That in module 2 we covered the classification of power quality events, then transient, its types, that is oscillatory transients and the impulsive transient. Then we covered long duration voltage variations, that is undervoltages and overvoltages. Next we covered short duration voltage variations, that is voltage sag and voltage swell, and lastly we see the concept of voltage imbalance. So students, for the complete understanding of module 2, you have to go through this assignment where 4 questions are there. From the screen you can copy them, and for any query regarding the concepts of power quality events, you can write to hadpe.somnath@gmail.com for the better understanding. Thank you very much. Thank you.